Hello everyone and welcome back to a new session Computer Science 2 LTU Summer 2022. This session is for Chapter 15, Inheritance and Polymorphism. I apologize, I should have posted this earlier in the weekend, but I'm very sick, so I'll try my best to cover what's coming in the test. Here in front of you, you see the test. I already prepared it. Of course, graded, it's out of 25 points because it's midterm. The time limit once you start is 110 minutes. You can't submit more than once. And it's going to show you the correct answer immediately, one question at a time. And then it's going to lock questions after answering. It's available from Thursday midnight, meaning you have all Thursday until Saturday also midnight, or Sunday morning. So you have all Thursday, you have all Friday, and you have all Saturday to start the test. After submitting this test, I should send you a new session which is Advanced Files Operation Chapter 12. With that being said, let's go ahead and start with our chapter. I have the book in front of me like usual, and it's on page 907, chapter 15, Inheritance, Polymorphism, and Virtual Functions. Don't worry about virtual functions for now. We might get back to it after the midterm. So what is inheritance? Inheritance, basically, you have a class, you have a base class. It has member variables, member functions, constructor, destructor, etc. Then you can inherit from that base class. If you use the term base, then the relative term is derived class. Or if you use the term parent class, then the relative term is a child class. So you either use base with derived or parent with child. Don't mix and match. Don't use base with child and parent with derived. So you have a base class, you would have a base class ready in place. It's written, prepared, you have the header file, you have the source file, and you're using it. Then you can build a class based on it, meaning this derived class will take all the above except constructor and destructor. So a base class has member variables, member functions. Then the derived class, just by the fact that it derives from here without the need to write anything in that class, just by the fact that it inherits from this class, then member variables will be included in the derived class, and the derived class will also have the member functions from the parent. So basically, the idea inheritance allows you to have a new class based on an existing class. The new class is automatically inheriting all the member variables and functions, except for the constructor and destructor, as I mentioned. So in a real life situation, let me remind you that inheritance is under the umbrella object-oriented programming. You're not going to see inheritance or polymorphism or virtual functions in a non-object-oriented programming language. So the fact that object-oriented programming reflects real life, we need inheritance. For example, in the real world, many objects are specialized version of other general objects, meaning, or for example, the term insect describes a very general type of a creature with numerous characteristics. It has special characteristics. So, for example, a grasshopper and bumblebee are insects. They have all the general characteristics of an insect. However, they have special characteristics for their own. For example, the grasshopper has its jumping ability, the bumblebee has its stinger, etc. So grasshopper and bumblebees are specialized version of an insect. So you can imagine it, the base class is an insect, and then the derived class is a grasshopper or a bumblebee or a bee or a fly, etc. In other example, for example, the base class would be a shape. Every shape has a name, has a color, has volume height, has volume width. Then you have a rectangle. Rectangle has a special characteristic, for example, number of corners, 4 corners, or a circle, 0 corners. So and the radius. So in both rectangle and circles are shapes, but a rectangle is a specialized shape with its own characteristics plus the characteristics of the shape. So the derived class rectangle will inherit from the base class all the characteristics and add to it the specialized member variables and member functions. Same for the circle. The circle will inherit every characteristic from a shape class, and it will have its own member functions and member variables, for example, radius, and a function, for example, the area. The area of a circle is computed different than of a rectangle. So this is the basic idea. And you need to know the book starts with the figure 15-1 for the insect and grasshopper versus bumblebee example. The book needs you to know about the is-a relationship. So a derived class is a base class. And you're going to see this later with polymorphism, meaning a grasshopper is an insect. A bumblebee is an insect as well. A rectangle is a shape. So so there is this relationship between derived classes and their base classes. The relation is a derived class is a base class as well. Meaning later you're going to see that if you're pointing at a derived object, you can give it values of base class because a derived object is a base class as well. For example, imagine you have a container of vehicles. Then you have a derived class that has, for example, Ford, GM, BMW, Buick, etc. This container of specialized vehicles can be declared as a container of a vehicle, because a GM is a vehicle, a Ford is a vehicle, a BMW is a vehicle. So you're going to see this in polymorphism. So that's what the book is trying to tell you in this topic. A car is a vehicle, a tree is a plant, a rectangle is a shape, a football player is an athlete. Derived classes is a parent class or base class. So in object-oriented programming, inheritance is used to basically create an is-a relationship between classes. That's what inheritance basically does. It creates, it links all those objects together. Also, it saves you time for rewriting or reinventing the wheel. If I have a base class and it's ready in place, and I need to write a different class that basically has all those, I don't have to rewrite everything. I just inherit. The fact that I inherited, now the derived class will have everything written already in the base class. So let's do some example for the coding. Let me show you how it's done. So for example, I'm gonna go back to a rectangle shape. So rectangle versus shape. I have a class called shape. This class shape has a private section, has a public section. In my private section, I have, let's do int for now. Int height, int width, and then I'm gonna have a string name. In the public section, I'm gonna have a constructor, default constructor for now, and I'm gonna do it inline for now. So in my default construction, I'm gonna say height equals 0, width equals 0, and name is an empty name. Then I'm gonna have an overloaded constructor. Overloaded constructor means it's a constructor that takes values from the outside. So int a height, int a width for argument, and then string a name. What I do with these values, basically, I say, okay, this height equals the argument height. This width equals the argument width. This name equals the argument name. Then I'm gonna have a getter and a setter. For example, I have a get width. This returns an int, return width. Then I have int get height. This returns height. Then I have string get name. This returns name. Then I have a set void set width. This takes an int a width. What I do with a width is I set the member variable width to be the argument width. I can do the same. This takes height, a height. This takes a height and sets it to height. And this takes a name as a string. It's called set name. And then it puts name equals to a name. So I have a humble class. It's called shape. Now, when it comes to the access specifiers, private and public, the private section of class is not exposed, even for the children of the class. Private section, nothing can access a private section of a class unless it's a friend, like we've seen last time. So even if a class inherits from shape, the inherited class or the child class or the derived class will not be able to access the private section. Anything from outside the class can access the public section, whether it's a derived class or if a class that has no relation to the class. Anything can access the public section. This is basically the interface of the class. This is how the outside world communicates with the class. It initializes instances of this class, it sets values, it gets values. So I'm gonna go ahead now and declare a derived class from that class called rectangle. So class rectangle, and then I'm gonna type colon. I'm gonna say public, and I will get back to the public shape. Now that I did this line, this means rectangle inherits from shape in a public type. I'm gonna go over public versus private versus protected inheritances later. So the fact that I did this, I'm gonna go ahead and put just a placeholder public. I'm gonna say rectangle does nothing. Rectangle. So it's an empty derived class. However, notice when I create an instance of this class, L-rectangle, notice that L-rectangle right away has all the methods from the parent, get height, get name. I didn't write these in the derived class. I wrote these in the parent class. But a rectangle is a shape. So that's why it has all these, get height, get name, get width, etc. Now notice if I move these to the private section, then it's gonna error telling that the constructor should be public. So let me move these. These are the private section, and then this is the public section. Notice the fact that I moved those to the private section, even if derived class doesn't have access to them. Those 6 methods that I seen earlier, those are private to the base class, so nobody can access them. This is very important. So I'm gonna move them back here. And then I'm going to introduce a new topic, which is protected. Protected section is in between, eventually, in between private and public. No class from outside the parent class can access the protected section unless it's a child, it's a derived class. So notice, if I move these 6 to the private section, as we've seen earlier, I don't have access to them. There is nothing. If I move them to the protected, now I have access to them. Shape public protected, yeah. What's the error? Add rectangle dot. Add rectangle dot get. How come? Because I did. Public protected. Why my system is acting private, public? Oh, yep, my bad. So basically, I'm trying to access them. I didn't notice the class. This is the class. So the fact that they are public, I don't have access to them from a public space. Only the fact that they are protected, sorry. The fact that they are protected, only the derived class has access to them. So for example, here, inside the class, not from the outside world, here I don't have access to them because those were protected. However, here I can say get width or set width. For example, let's say this a function, this rectangle has set data, and it has int a height, int a width, a string a name. Notice inside this class, which is derived, I have access to them. So I can say set width, for example, a width, set height, a height, set name, a name. So now the fact that this has access to them, I can also access them from the public. Now that this has a set data method, I can give it 1, 2, rectangle. So the derived class exposed a method to the public world. And since set width, set height, set name are declared protected in the parent, that means the derived class rectangle has access to them. So a public method accessing protected member functions from the parent. It's still limited access because public, it's true that this is public, but you can set them based on your condition, based on whoever wrote the class design. For example, if the width, I can control it by saying if the width is negative, don't do anything. If the height is negative, don't do anything, etc. Or see out, or I can control it. So the public word can't just set values randomly. It's controlled by the class. So the next topic is private versus protected versus public inheritance. So let me, here you see it is public. It's inheriting from shape as public. We still have protected. Don't confuse access specifiers with the inheritance type. These are two different things. So paint. Oh, no, not this. You stay here, give me this. So you're gonna have, you can imagine a table. One, two. So 3 columns. And here I'm gonna type what's what do I mean? So imagine I have a member variable declared how the member variable is declared in a parent class. Oh, this is bad. No, let's do this. Oh. So again, how a member variable is declared in a parent, in the parent class. Then the inheritance type, inheritance type. Then how a child class inherits that variable. Imagine I have only one variable and I have three types. So I have public or private inheritance. Then I have public inheritance or protected inheritance. And for each type, a variable can be declared as three things. It can be declared whether it's a private inheritance type or a public inheritance or a protected inheritance. This variable in the parent can be declared either private, or protected, no matter how the designer declared it, or basically we're covering all the cases. So this member variable we're talking about, it's either declared private or protected or public. So I'm going to take a copy of these. As a matter of fact, I'm going to take a copy of the whole thing. Dump it here. And then here. So for each type, I have all the cases. Now the inheritance type can be private. The inheritance type can be protected. The inheritance type can be public. Now, I also have three cases in how the child inherits that variable. If it's a private, let me put the three cases. If a member is, let's choose blue. If a member is declared private in a base class, the child doesn't have access to it. No class, whether it's derived or not, no class has access to the private section unless it's a friend. So all these private cases, no access. No access, unaccessible. This also, this, whatever the type of the inheritance is, no access to the private section. Then, if the inheritance is private and a variable is declared protected, then the child will inherit it as private. So it's protected in, the member variable is declared protected in the parent, then the child inherits it as private, meaning, give me what, meaning the class would assume object oriented. The class would say, the child class would say, give me what I have access to and set it to private. Meaning I inherit, the child inherits the private, the protected member variable from the parent class and declares it as private in its own class, meaning nobody can access it. The public as well will become private. So you're basically hiding the data. In a private inheritance, you're hiding the data. The child is hiding what it has access to. It has access to protected, it has access to public, so it's hiding it because the inheritance type is private. We come to protected. Protected will stay protected. So a protected member variable in a protected inheritance stays as protected. Public member variables in a protected inheritance will become protected. Then if the inheritance is public, like we just saw, it stays as is. So a protected member variable in the parent stays as protected, and a public from the parent stays as public. So you need to memorize this. You need to see the difference types. You need to memorize what the child class has access to and what not. Okay, so this is what the book is trying to say in this topic. Back to this, I'm gonna show you how for topic 15.3, constructors and destructors in base and derived classes. So let's add a constructor and a destructor. So we have a constructor, let's add a destructor, shape. And then I'm gonna say cout goodbye from shape. In the constructor, I'm gonna say cout hello from shape. So whenever a shape object is created, I'm gonna see this on the screen. I'm gonna also move it to the overloaded constructor. I'm gonna do something similar in rectangle. I'm gonna say cout hello from rectangle. Then I'm gonna have overloaded constructor. Of course, I have the set data for demonstration, but we don't need it. I'm gonna move this hello from rectangle and then set width, set height, set. So I'm gonna remove set data because we no longer need it. We no longer need this. I'm gonna set height, width in the rectangle here. Then I'm gonna add one more. Oh, these are private, so I can't access them using because height is declared private. It's private, no access. Remember, no access, private, and public inheritance, no access. So I'm gonna use the public methods of the parent. The parent exposed these methods. With that being said, let me add to the rectangle, for example, int num of corners. And it's always 4, but I'm just trying to demonstrate having an additional specification in the derived class. So here I'm gonna say number of corners equal 0. As a matter of fact, we can call it it's correct. Keep it as this. I'm gonna do this as well. Number of corners, a num of corners, and this is an int. So this goes here. Then I need you to know, or the book needs you to know, and the base class's constructor is called before the derived class constructor. Then the destructor is in the reverse side. First, we destruct the derived class, and then we destruct the parent class. Imagine you have a building. Whenever you have a building, you have the parent, right? Parent. And then the child class is built based on the parent. So the constructor, you can imagine a building, first floor, second floor, third floor, etc. So when constructing your instance, for example, when I called rectangle a rectangle, I'm constructing a rectangle. When I construct a rectangle, the parent constructor gets called first, then the child gets called the constructor. If I'm destroying an object, then it's the opposite. First, we destroy the one on top, and then we destroy the one on bottom. Because if we destroy the one on bottom, imagine a building. If you have 5 floors building and you destroy the first floor, then it's gonna collapse. We can demonstrate that by showing it here. Remember, I have hello from rectangle, hello from rectangle, and then a destructor. Notice, see out, goodbye from rectangle. So I'm gonna put a breakpoint here, put a breakpoint in the default constructor. I'm gonna put here, and then I'm gonna put here. However, one thing you need to see is, well, we can we can move on with the example. So I'm constructing a rectangle. When I hit F10, notice the shape gets constructed first. Hello from shape. Then the rectangle gets constructed. Continue, continue. How is that? Set name. Oh, this needs to be a string. It couldn't evaluate it. Go. So notice I'm in the rectangle now. Hello from shape, hello from rectangle. So the parent class got constructed first, then the derived class. Notice when I reach the end of my software, then the derived class gets destructed first. This gets destructed first, and then the parent gets destructed last. So notice, hello from shape, hello from rectangle, goodbye from rectangle, it's the opposite order. Also notice if I have to. If I have to, this will be constructed, meaning the shape will be called, and then the rectangle will be called. Then this similar fashion, the shape will get constructed, then the rectangle will get constructed. When I reach the end, it's the opposite order. This will be destructed first, then this will be destructed first. In order to destruct this, it's gonna destruct rectangle for this object, then shape for this object. Following it, it will destruct rectangle for this object and parent for this object. So notice it's gonna say hello twice. I'm gonna move on, move on, move on, move on. Notice hello from shape, hello from rectangle for the first instance. Then hello from shape, hello from rectangle for the second instance. Notice now when I continue, go, 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 go. Notice it for the first instance, which is rectangle 2. I can actually display the name for you. Hello from rectangle. Name. I mean member variable name. Get name because it's private. Hello from goodbye from rectangle. Hello from rectangle, get name. Goodbye. Hello. Hello. So get name, get name, get name. Notice, let's give it some values first. I'm gonna say that this rectangle is 1, 2, 1. I'm gonna say that this is 1, 2, to just for the sake of demonstrating. Of course, it's not gonna like it because nonsense of constructing rectangle matches the argument list. And oh, okay, it needs one more for the number of corners. Now notice, I'm gonna kill all breakpoints. Continue. So hello from shape, hello from rectangle 1. These two lines are for the first instance. These two lines are for the second instance. Now when I continue, notice that 2 gets destructed first, and these two lines are for the second instance. First, we destroy the derived object, then its parent. Then we go to the first instance we created. First, we destruct the derived class for it, and then we destroy its derived parent class. So now you know the order of constructors versus these structures. Now, next thing you need to know is you can, without having a setter and getter like here, for example, I'm going to remove this. I don't need this for now. And I'm going to remove this. Imagine it's a private. Only this belongs to the class, so I can control it. You can, or basically you should, pass all the parent class member variables through the constructor. When someone constructs a derived class, then you need to pass the needed member variables to the base class. So you write colon and then the name of the class, the parent class. Notice then you pass it a height, a width, a name, even that they are declared private. I was able to pass those needed member variables to the parent. Remember, when constructing, it needs to construct the parent first. So when constructing a derived class, you're giving it all the values, both for it and for its parent. Then you need to pass the needed variables to the parent class, even if they are declared private. So this says how you pass from a passing argument to the base class constructor. Okay. Here, the book is trying to tell you that in 15.5, topic 15, class hierarchy. Basically, it's trying to tell you that a base class can also be derived from another class. So I'm going to delete all these. We don't no longer need it. It's basically telling you that if I have a parent class, then a child class can inherit from it. Then another child can also inherit from it. You can have multiple inheritance. You can have chained inheritance. So for example, you can have this example. You can also have this example, parent 1, parent 2, and a child inherits both. For example, imagine this employee or let's say a human or employee, yeah. For example, this employee, child, employee is a manager and also a student. He goes to classes. He's working on his other degree, student. So this employee inherits both characteristics of a manager because he's a manager, and also inherits all the characteristics from a student because he's a student as well. He has a student ID, he has a manager vacation days, he has number of people reporting to him, etc. Number of courses. So so you have this chained or this change, or you can have again two childs, one that inherit from the same parent, which is the example we gave earlier. You have an insect, you have a grasshopper, you have bumblebee. Both of them inherit from the same parent. So this is called class hierarchy. Then there is a topic redefining base class functions. So let's say I have a method here called display. This display counts high from base. Void, and it's public. Then then I can I can have the same method that redefines, have the same name, but it redefines the member function in the parent, basically having the same different body. For example, this display says cout high from base. Here I can say high from derived, and then also call, for example, the one I need, which is display. I can call it, I can ignore it. Let's say I ignore it just so you don't get confused. If I call display, remember when we said a child inherits all member functions and all variables from the parent. So I have a display here, and I also have a display here. When the child calls display, since it has its own version of display, then this will get executed. If the child doesn't have it, then it will inherit it from the base. So notice, if I go to my rectangle now, and I say, hey, rectangle dot display, it's gonna say hi from rectangle, because rectangle has a display method, hi from derived. However, if it doesn't have it, and then I call it, let's remove all these out so we no longer see them. I need this display. Yep. High from base. High from base because the base, the derived doesn't have a display. If it has a display, it will execute its display. It can also execute the parent display. So now it's going to say high from derived, high from base. This is called redefining base class functions. Then we go to chapter 15.6, I mean topic 15.6, which is polymorphism. Excuse me. Okay, so the next topic is polymorphism and virtual member functions. The concept behind polymorphism is, let's type the definition, maybe it's better if you read it. Polymorphism, basically, polymorphism allows an object reference or a pointer. It doesn't work unless it's a pointer. This is very important. Polymorphism doesn't work unless it's a reference or a pointer. allows an object reference or a pointer to reference objects of different types and to call the respective member method. member function. That all depending on the type of the object being referenced. What does this mean? This means, imagine I have this rectangle, and I have a display method. Then I have another class called this display. I'm going to tell it to display I am a rectangle. So the type, whoever invokes this would be rectangle type. Shape is going to say, hi, I'm a shape. Then I'm going to have a new class called, for example, circle. Circle is a shape as well. So I have a circle. This circle has, for example, and radius. Radius. This circle takes wherever it needs from for the base, and then a radius additional radius equals to argument radius. Circle has a constructor as well, and it has its own display. So every parent or parent and both children have a display method. Now notice if I create shape, L shape, and I give it 1, 2 shape, and then I say, hey shape, display. This is not a reference. This is a value. It's an instance, not a reference to an instance or a pointer to an instance. It's an actual value. So I have this in place. I will do the same for rectangle, L rectangle, 1, 2 rectangle, 4 corners. Then I'm gonna say, hey rectangle dot display. I'm gonna do the same with L circle. The circle takes whatever we need for the base plus a radius. I'm gonna say 5. I'm gonna also say display. So this, just like how we showed earlier, it redefines the member method from the parent. The fact that display has a shape has a display, it will execute the body from the parent. The fact that rectangle has a display method, it will execute the method from rectangle, similar to circle. The fact that the circle has a display method, it will display its body. So I'm gonna say hi from I'm a shape, hi I'm a rectangle, hi I'm a circle. At this point, this is still not polymorphism. Polymorphism kicks in when I'm working with pointers. Notice I'm gonna say shape, L shape 2, and it's a pointer. And with dynamically allocated memory, I can say shape, I need this shape to be new rectangle. Then I can give it whatever it needs, shape 2, for example, and then 4 corners. I'm gonna comment these out. Notice you might argue that, hey, how does this work? How are you pointing to a shape, but you're telling it it's a new rectangle? This works because of the is-a relationship. A rectangle is a shape, so I can do that. Notice now, when I say, hey, shape, I need you to display. Back to our definition. It's a pointer, so it needs an arrow. Back to our definition. Polymorphism allows an object reference. This is an object reference or a pointer. Shape 2 is a pointer to shape, to reference objects of different types. So this pointer is referencing different type, basically a derived type. and to call the correct member function. The fact that this pointer is a new rectangle, then display of the rectangle will get called, not display of the shape will get called. This is, in brief, this is polymorphism, and this is all you need to understand about polymorphism. Depending on the type of the object being referenced, what type being referenced here, it's a rectangle. So if I execute, it's gonna say, hi, I'm a rectangle. Oh. Oh, I have to declare it as virtual. Virtual. Also here, virtual. So by telling it that this is a virtual function, also here, meaning I'm activating polymorphism. I'm allowing polymorphism. Otherwise, if I use no pointers at all, for example, I'm gonna say I have a rectangle, L rectangle of 1, 2, rectangle 4. And then I say I need a shape, no pointers. Shape that is equal to rectangle. And then I say shape 2 or shape dot. This is back to the previous example. However, I need you to look at this line. This line is not the same as this line. This right now is referencing a different type of object. However, this is doing member-wise assignment, if you remember. When you assign different types and they are derived, what happens is called slicing. What's gonna happen is the relative member variables from this rectangle will be assigned to shape, and everything specific to the rectangle will be ignored. So shape is gonna say, okay, I'm assigned to be equal to a rectangle, but shape, it doesn't have number of corners. It has number of corners. The variable that is declared only in rectangle has been sliced. So do not confuse this with this. The display for this will call shape, even that it's a virtual function. I am a shape. However, this is polymorphism. By telling it this method is a virtual and I'm inheriting from the parent, then I can have a container of shapes. Every piece is a different type, a different child. For example, I can say for the user, what would you like to have here? Hi user, what would you like to have? Would you like to have a shape or a circle? Look, I'm gonna have C out. Enter your choice. 1 rectangle, 2 circle. And I'm gonna have shape pointers L container. I have a group of shapes, L group. Or we can have it as vector of shape pointers called L group. I need to include vector. Now that I'm ready, see out, enter your choice. If the user says do while a choice equal or is not equal 0. So I'm gonna keep doing this. Int L choice. So grab this, put it here. Then I'm gonna say rectangle 2, 0, exit. Cn into L choice. So now if L choice equals 1, that means the user chose a rectangle. I'm gonna say start or declare pointer to shape L temporary temporary because I'm gonna push it back and then I'm gonna delete it at the end, is a new rectangle. Why it's a new rectangle? Because that's what the user selected. Rectangle 1, 2, rectangle 4. Else, if L choice equals 2, because I don't need to cover the 0, then I'm going to say it's also a pointer. Temp equals new circle this time. 1, 2, circle, and the radius is 5, for example. Now that I started them, I'm going to say to my group dot pushback this temporary variable. Of course, it doesn't know about it, so I'm going to move the declaration to here. And then I'm going to just assign it inside my statements. Now that this has been done, I'm just going to iterate my group. Auto L item in my group. Maybe I don't have this like this. Then I'm gonna see out L item dot display. Oh, I'm just gonna, this doesn't return anything, it's a void, so it will display. Notice I'm gonna run. Actually, let's run by stepping into. With F10, I notice that I have a group or a container of shape pointers, not specific to a rectangle, not specific to a circle. Then I'm gonna ask the user, hey, what would you like? I would like rectangle. Now that you chose rectangle, I'm gonna say that the existing pointer or the current pointer is a new rectangle, and then I'm gonna give it some value. Then I'm gonna push this pointer to my group. Then I'm gonna ask again, I'm gonna do 2 rectangles and 1 circle. So this is the second rectangle. Then I'm gonna do a circle. Notice now it's gonna say this pointer that I created is a new circle. Push back. Now I'm gonna exit. Oh, I did push it back. I shouldn't have pushed it back. Anyway, notice in my group, I have pointers. All these are shape pointers because my group is a vector of pointers. However, the display method will kick in based on what the pointer is referencing. If the pointer is referencing a rectangle, then it will call the display of the rectangle. If the pointer is referencing a circle, it will call the display of a circle. The fact that this is declared virtual allows me to do this. I have only one group. I can pass, let's say you're a different programmer in my team. We agree that our methods are gonna interface by a container of shape. I can populate, let's say my function is gonna call your function and give you the container. We can agree that the container is a shape. Then in your code, I can call your method and pass you a vector of shape. Then in your code, you can deal with those pointers based on what they are referencing. If they are referencing a rectangle, then you're gonna have virtual methods that will kick or execute the rectangle methods. If the pointer is referencing a circle, it will kick in for a circle. So notice now, first 2 are rectangles, second 2 are circles. The last one is shouldn't be here. I can, as a matter of fact, move this to here. So if it is the case, push it back. If it is the case, push it back. So run again. I need 1, 1, 1, 3 rectangles, two circles, exit. So now I have three rectangles, two circles in one general container. This is polymorphism. And it is powerful. It is used in the field, as I mentioned, because it generalizes the container, but it references specific type. Then the book says polymorphism requires references or pointers, which we did already address. The book wants you to know about override and final, but we don't worry about it for now. And topic 15.7 also is not needed for the midterm. We can get back to it on after midterm. This is everything you need for the midterm. So I hope you guys study well, and let me know if you guys have any questions.